Welcome to this video, and in this video we will learn about computer vision. This is a niche segment of artificial intelligence and it is growing at a rapid scale. And we will understand what is computer vision, what are the models that we are using in computer vision, and what are the industries they are adopting it, what are the market size, what is the benefit of it, and as a professional how you can leverage, and what are the benefits that as a working professional or an engineer of computer vision you can get the value out of it. Let's first understand what is computer vision and how it works. Visual detection and quality control systems. We will be developing the complete system. We will be starting from the foundation concepts and understand what are the defect engineering, and finally designing and developing the complete vision detection system. First thing first, let's understand the market stats and the adoption. Like currently we see that the market size is $20 billion in 2026. And I would say this is around 7 to 8% of the total global AI market. It is growing, and you will see that it will pick up the pace in couple of years. The CAGR is 15%. It is growing annually. And if you see that to do a production ready investment, companies are investing anywhere from $250,000 to $800,000. This is for the complete production life for computer vision, including models and all the hardwares that is involved in the production line. And they are getting break even in within a year if you are considering around a high volume production line. And if you consider the human cost, if you are trained on the computer vision models and you are able to monitor and operate the models, you can anywhere get around $150 to $300 per hour. And speed, if you consider manual inspection and the artificial intelligence inspection of any of the smaller details like finding a scratch, then it will somewhere around take around 4 hours to for a manual inspection to 18 minutes on a particular batch size of spare parts. So this is about the market stats, and it clearly shows that the market is really good for computer vision. It is smaller, but it is a niche segment, and the growth rate is also pretty good. And it is predicted that this is going to pick up the pace sooner. So major market players in the automobile industries are Tesla, BMW Group, Mercedes-Benz, and Ford. So we are considering only automobile sector here. We will be also seeing like what are other sectors where computer vision is being used. So primary purpose is full self-driving, manufacturing quality, like detecting the defects in the spare parts or the alignment of the alignment of the complete part of a vehicle. And this is the high ROI investment, because the organizations who are investing in these technologies, they are getting the returns within a year. There is very few investments which are giving these kind of returns, especially in the manufacturing units. Human inspection gets tired over time, whereas AI works 24/7. There are inconsistent results when a person is inspecting a spare parts, but in case of the AI, it is a consistent, and every time there is a subjective judgment, but while in case of AI, it is objective and measurable. So the core insight is the AI is not replacing human because it is smarter, but it is replacing because it is more consistent. These are the industries where the computer vision is being used: in the automotive, like full self-driving cars, defect detection on metal parts and assemblies. And in food industries, we are using to grading the food, basically like mangoes. So we are seeing that if mango is rotten or not, or there are the rice, we are segregating the black uh, particles in the rice, and these kind of things are happening in the industries. So in the food industry, there are many use cases that you can use in fruits and vegetables, segregating from good or bad, or some kind of pulses, rice, and segregating and putting into different buckets based on the quality of these cereals. Similarly, in logistics, there is a damage detection on package and shipments. Healthcare industries diagnosing the medical images and scans. Now let's come to the crux and the concept that we want to understand: what is computer vision? That's the million-dollar question and most fundamental thing to understand. It is the ability of machine to see, understand, and make decision from the images. The primary goal of the computer vision is to see at the image, understand and get the information, and then it is using different type of models to do that. There are CNN, there are vision transformers, there are VLM, which is a vision language models. Each have its own strength and purpose that they are being developed. So this is how the CNN is working. Consider CNN convolutional neural network as a magnifying glass, and we are putting that glass over the object and rolling around the whole object to understand what this image is all about. And also we are understanding what exactly we are going minute details on very small size or the small portion of that object. So as you can see in the screen, this convolutional is, so this is the magnifying glass. This is a, you can say a rubber stamp or a magnifying glass. So I am taking this glass and rolling over the complete the object. So in this case, the object is car. So I want to identify if there is any kind of scratch or any kind of dent, or there is a spare part which is not placed or properly, it is not aligned with the overall structure of the car. So that's what I am trying to identify in this car. So what I will do is I will be rolling over it, and at a time I'll be seeing one particular portion of this whole vehicle. And there I will be this convolutional neural network will identify, okay, this is, if there is a scratch, then it will say, okay, I see there is a line, and I see there is some kind of dark patches over there, and then it will roll on to another place, then it will say the texture is a metallic shiny object, the shape is a square, something like that. Okay, so this is how I will be scanning, and it will be giving me the data out of it. This is how the convolutional neural network works. I hope it is completely clear to you what is CNN and how it works. Okay, so these are the models. So basically CNN is a, you can say computer vision is a goal to see and understand the things. And to do that, there is a tool called CNN. There is a model called CNN to visualize the object by the artificial intelligence. I hope now it is little better or more clearer what CNN is. Okay, let's move to the another tool, which is VIT. VIT is the vision transformer. So as the name suggests, it is a transformer which is based on the NLP models, like large language models. And when I say it is based on the transformer, it means that it is considering one object or one portion of it to all other portion in this particular image. It is similar to how the LLM works, how the ChatGPT works. When you are giving the prompt, it is analyzing each token with all other tokens so that it gets a clear understanding about all of the things that is happening in that the particular prompt. So, okay, so it is the global understanding. It understood what exactly you are looking for. Similarly, in vision transformer, what it is doing is it is dividing the whole picture into blocks or patches. As you can see, there are the patches. It is like blocks, like we have a Lego blocks, right? So it is dividing the whole image into patches. And then it is analyzing each patch one by one, not alone, but it is considering all the patches. Like for example, it is considering this patch number 1, and it is analyzing it with all other patches in this image. Okay, so this is how this line is going to other patch as well. And then similarly, it is analyzing too with all other patches over there in this whole object. I hope you got the clarity. What is vision transformer? So it is not analyzing in isolation like we see in the CNN, which is faster, but it is little bit slow, but it is getting a global understanding of what is happening around this whole the object basically, and in this case it is the car. Okay, so it is clear, right? So what is VIT? Vision transformer. It is dividing the image of a car into a multiple patches, and each patch it analyzes considering all other patches in the object. Let's move on to our third model, which is VLM. This is Vision Language Model. So what it is a combination of your visual model, which is like it can be a CNN or it can be VT, Vision Transformer, and also apart from this the vision model, it is also having the LLM, which is the large language model. Okay, so it is a combination of these two. What are the advantage of it? Advantage is like you can talk to this model, and this model will communicate you back what it has found in a natural language. That's the power of it. So as you can see in this screen, so it is having a bracket. So earlier we see in the VT we have the patches. Here it is having the brackets, and it is rolling over these brackets over the images and understanding the pattern in each bracket. So this is your central hub, where it is getting this information about this particular bracket. And apart from this, the vision identification which it has done, it will also attach the meaning or the text around it. So for example, I said identify the scratch on the surface of the car or the surface of the object. So it will attach that meaning to this bracket and store this information into this central, which is glowing, you can see, right, this glowing object. So it will be storing this information, all the brackets and the contextual meaning of this to this central location. This is all about the VLM. Okay, so it is a combination of the vision model and the language model, so that you can interact and this can interact you back. It is like chat GPT, we are interacting. That is the power of VLM. So now we have understood these are the three models which are working behind the computer vision, and I'm sure that now you got the clarity what the computer vision is and what are the different models and how this computer vision is achieved in it. And we have seen the example of automobile industry. You can use this in any other industry, like we have seen that it is used in food industry, medical industry, so on and so forth, logistic industries, etc. Great. I hope you enjoyed learning about the computer vision and its models that it's using and how it works. If you want to learn how to build a system step by step and what are the tools required, how you can build a production grade system that can directly used in the manufacture plants to detect the anomalies or discrepancies in the spare parts in the real world, join my free masterclass and I'll show you how you can think, build, and lead this AI era. Link is there in the description. Join my free webinar and you will get the clarity, you will get the confidence to lead this AI era, and I'll show you the roadmap exactly how you can navigate through it.